Welcome to The Explainer. I am absolutely thrilled to have you here today. If you love going down the rabbit hole, you're in the right place because we're essentially putting on our digital detective hats for this one. We're going to conduct a forensic digital autopsy, embarking on this wild macro to micro descent that bridges the digital decay happening right beneath our screens all the way to the foundational quantum physics of the universe.
Okay, so let me ask you something that might sound a bit like a riddle. What does the collapse of the internet actually have in common with a black hole? It seems totally out there, right? It's a mystery, bridging two vastly different scales of reality. On one hand, we've got our everyday human digital networks, and on the other, the absolute deepest cosmic anomalies in astrophysics. But, as you'll see by the end of this explainer, these two systems are actually bound by the exact same tragic thermodynamic laws of memory, entropy, and information loss.
To really get into this, we first need to establish the massive, macro-level stakes of what we're looking at. One of the researchers in our sources perfectly encapsulates this terrifying reality with this quote: "Google is a snake eating its own tail." I mean, wow, we're looking at a built-in architectural paradox. The ultimate answer engine on the web is now mathematically destined to consume its own food supply. Let's break down exactly how we got here.
This self-cannibalization is what we call the AI siphon effect. And the contrast here is just stark. Think back to the old web. It used to be this thriving digital commons, right? Just rich with diverse, human-authored voices and independent experts. But now, we are rapidly moving toward a new AI-gated reality. Search engines are absorbing vast amounts of human-written content and using AI to summarize it, just handing the reader the answer directly. The original human writer basically gets reduced to an ignored footnote. And those independent expert sites? They're completely starved of the traffic they actually need to survive.
Now, the driving force behind this collapse boils down to a pretty terrifying statistic. Get this, an estimated 80 to 90% of AI compute cycles rely entirely on hardware approximations rather than exact math. To really understand the collapse of the web, we have to descend all the way down to the silicon metal itself. When these massive large language models do their heavy lifting, they aren't actually doing real precise arithmetic. They are essentially just guessing the nearest mathematical truth.
Let's dive into the actual mechanism here. Researchers literally call it the hardware wood chipper. The main culprit is this microscopic piece of hardware called the FPU gambler, or floating point unit. So to process massive amounts of data super quickly, it estimates math by doing this microscopic rounding, literally dropping tiny fractions in what's known as the 23rd bit chop. Think of the FPU like a giant blender. You know exactly what fresh fruit you put into it, but once it's chopped up by that microscopic rounding, it's a smoothie. You can never unblend a strawberry. And because of this, true forensic traceability, the actual provenance of the data, is permanently destroyed.
So how does this blender effect guarantee an inevitable disaster? Well, we can map this out in a devastating 5-step timeline. Step 1, a human writes an original brilliant thought. Step 2, an AI summarizes it, effectively stealing the traffic. Step 3, deprived of revenue, the independent expert site dies. Step 4, because that original human source is gone, the next generation of AI is forced to train on its own lossy, degraded summary. And finally, Step 5, total semantic collapse. It isn't just a possibility, it's a mathematical inevitability.
And you know, this digital decay isn't just some tech industry problem, it's fundamentally anchored in the laws of physics. We can look at Claude Shannon's rate distortion theory, which proved that anytime you compress a signal, you introduce measurable degradation. Crucially, errors can only be remedied if the noise remains below a 50% threshold. But by absolutely flooding the web with synthetic, approximated AI data, we're breaching this physical law. The genuine human signal is crossing that threshold, meaning it's permanently lost to algorithmic distortion. But hey, it's not all doom and gloom. There is actually a theoretical escape hatch to this AI data rot. Enter the non-halting feature. Instead of relying on these hardware approximations that degrade over time, we can rely on exact, unpredictable mathematical sequences. We're talking about things like the A249270 prime constant or the MITS non-halting hair. By repurposing these complex mechanics as cryptographic features instead of treating them as bugs, we demand precise calculation, completely resisting that lossy guesswork of the FPU blunder.
By utilizing this exact non-halting mechanic, we can create what's known as an unassailable forward-flying arrow of time.
This basically creates a perpetuity environment. It's the exact kind of deterministic shield that is absolutely required for unbreakable blockchain ledgers. By forcing the hardware to compute precisely rather than just guessing probabilistically, we can actually protect provenance and ensure that the chain of title for human thought remains perfectly intact.
Now here's where things take a turn. This irreversible blending, it isn't just a quirk of silicon. We see the exact same tragic thermodynamic law playing out at the quantum level, a phenomenon called page scrambling. Scrambling happens in a complex, chaotic system where information becomes completely mixed in the degrees of freedom. Basically, if you drop a tiny bit of information in, it thermalizes, becoming completely unavailable unless you can somehow analyze more than half of the entire system at once.
To visualize this, just imagine a complex system of qubits, like the circuit mapping out right here. It's evolving through a two-local Hamiltonian. So at each time step, qubits are paired randomly, interacting through random gates, and then regrouped. Just like the data dropped into the wood chipper of the internet, a single quantum perturbation interacts, spreads, and thermalizes until it's completely indistinguishable from the rest of the system.
This dynamic leads to what physicists call the fast scrambler effect. In a precursor switchback, if a perturbation is introduced, the operators effectively run backward in time, apply the change, and then run forward again. The result of that? The perturbation spreads through all the other qubits exponentially fast. We're talking about achieving total scrambling saturation in just a logarithmic number of steps. The information is just utterly and thoroughly mixed.
Let's just pull back for a second and look at the structural parallel we've uncovered here, because it's pretty mind-blowing. On one side, we have digital semantic collapse, driven by FPO hardware rounding and vanishing point probabilities. And on the other side, quantum complexity, driven by fast scramblers and the saturation of quantum states. Whether it's silicon circuits dropping data or quantum environments scrambling qubits, both are governed by the exact same lossy thermodynamics. Information is irreversibly blending into the background.
And that brings us to literally the ultimate fast scramblers in the universe, the black hole. We are descending way further into theoretical cosmology here. Black holes have these stretched horizons that act precisely like the thermalizing two-local quantum circuits we were just looking at. If you drop a bit of information, let's say a photon, into a black hole, it creates a local perturbation that spreads out until thermal equilibrium is reached. The black hole perfectly scrambles the information into its degrees of freedom.
Which brings us to the totally mind-bending ER-EPR theory. This theory suggests that high-level quantum entanglement, the kind of extreme complexity and scrambling we've been talking about, directly creates the physical geometry of an Einstein-Rosen bridge. A wormhole. Yes, the sheer complexity of the scrambled information literally bends the architecture of reality itself. How cool is that?
Okay, but let's bring our focus back down to Earth, to our digital reality. Because unlike a black hole, we actually have the power to fix our architecture here. To reclaim the digital commons and save the internet from thermodynamic collapse, we need to be proactive. First, we've got to shift away from those probabilistic FPU gamblers and start using exact deterministic ALU surveyors. Second, we need humans actually applying the sweat of their brow to manually prune and verify the output. And finally, we need simple licensing to enforce verifiable digital property rights for human creators.
So the architecture to fix this definitely exists, but the clock is ticking on the open web. I want to leave you with a final, provocative thought to really ponder as you navigate your digital life today. Are both the human internet and the physical universe bound by the exact same tragic laws of memory and entropy? If our networks truly share the ultimate mathematical fate of a black hole, what happens when we finally run out of true things to say? Keep learning, keep questioning the systems around you, and hey, thank you so much for joining me for this explainer.